What's up people, and welcome to my tutorial in Pragmatic Data Science. So in the previous tutorial we looked into this linear model that we have where we can tweak all the knobs in order to get really nice output, right? And what I want to continue in this tutorial is the discussion of how we actually perform this multiplication right here. Because we did this in a loop here where we iterate over all the values and like combine this weight with x1 and this weight with x2 and so on, and then we sum them up here with the plus equal sign. And in terms of output, that is totally fine to do that, of course, but what happens is, like when you have bigger data sets, where you have huge data sets, this kind of iteration it can be a bit problematic, because also it creates a lot of code basically, and also it correlates very badly with the kind of theoretical work that is being written in academic papers, which uses linear algebra most of the time instead. So in order to deal with that, we're going to take a look at some of the stuff that NumPy gives us. So as usual, I've prepared some data set here, and if you are a bit observant, you can see that this weights is now a NumPy array. And the data set is still a NumPy array as previously, and we also do the normalization and everything that we did before. And also I still need to iterate over all the data as before in order to reverse each row. And this, at this point, this doesn't really matter. In terms of performance, I don't think there's going to be any big difference here. But this is for learning purposes only. And what happens here is, now that I have two NumPy arrays here, they're really nice because they have this function called .shape that looks like this. And you can do that with NumPy arrays, but you can't do that with regular Python arrays. So that is why I also use a NumPy array here. So let's start by just printing out what the shapes of these different matrices are. So if I start here and then I run the program, I can see hopefully the shapes of the matrices. So you can see the shape of the data matrix is like this many rows and this many columns. So 4081 columns. Or sorry, it's the opposite. Sorry, it's 4081 rows and 28 columns. And the weights matrices is 28 columns, and it does this to show that it is either unknown or 1. So this, you can think of this as 28 times 1. And I use the word matrix here, and that is technically not correct, because since this only have one column, it is a vector actually. But it's going to work the exact same way, and you can think of it either as a vector or a matrix with one column. It doesn't really matter at this point. So what we're going to do here is we're going to take this data here, data matrix, and we're going to multiply it with this vector right here. And I know, like, sometimes when I started checking out how matrix multiplication work, I was so mind-boggled when I started to look into it, because, like, why do you have all these complex rules? And the reason why you have all these complex rules for how you multiply them is because of what we have been doing in the previous tutorial. Because if you multiply them in that way, it is really easy to do this kind of stuff where you have weights that you multiply with and then you sum up and everything. And I'm actually not going to do too much deep dive into the actual matrix multiplication, because I feel like there's a lot of good resources out there for this already that does it this much better than I do actually. So in the notes 8 here, I put some links where you can see matrix multiplication from Wikipedia, some other StudyGate, and a YouTube tutorial on linear algebra from Khan Academy. But that is a different story. So I'm just going to touch briefly on the subject. So if we take a look at this matrix multiplication, the Wikipedia article, you can see here that there are some important aspects when you do that. So like when you multiply two matrices, you can see the intuition here. You select one row for the first matrix, and then you select the first column. And I intuitively think of like where these intersect, that is going to be the value for that column, as they have illustrated here as well. So if you think of, you like overlay them together, you're going to see where that is going to end up. So basically here, when you're grabbing this value, or the red one here, you're going to take A11 and multiply it with B12, and then you're going to take plus A12 and multiply that with the B22. Basically exactly the same thing as we have done when we do this score calculation here. So what this means is basically we can take the constants and keep them in one variable, and then we can take the x values and keep them in a separate matrix. So you're going to have two matrices where you can just multiply them together, and this is going to work straight off, so right off the bat. So the mechanisms that you get for this is, when we are going to do the matrix multiplication here, I filled in the number 1 here, just because it has that shape, and it makes more sense if you think of it like 1 instead of empty or whatever. So the way this is going to work is, first off, when you multiply two matrices with each other, the order matters. Basically, this thing here, if you switch these around, in ordinary multiplication, regular multiplication, this will be the same thing. But this is not the case in matrix multiplication. This is going to do something else. Actually, you cannot even multiply them together, because it's not possible to do that. So one really common rule that people use is you check the adjacents here, like these two variables need to be of the same shape, in this case 28. So that is your way of checking if it is even possible to multiply them together. And as long as these two are the same thing, it's possible to do it. And the other two variables, in this case 48,081 and number 1, those two variables are going to define the size of the matrix that it's going to create. So basically 4081 times 1. So it's going to create a vector. So in our case, what this is going to do is going to have 4081 rows, which is going to be all the days from the data set. Basically all of these here are going to create a separate row in the vector. And it's going to have one column, and the column is going to contain the score for that particular day of the weather. And from that point, this is really straightforward. I'm going to use the NumPy matrix multiplication function. And also, you need to be careful when you do this that you actually use the matmul function here, because there is also a function called multiplication or multiply, which does not multiply matrices. It does something completely else. So be a bit aware of that, because that was something that I did and was super confused about. So let's just print the scores, the shape of these scores, which we can do because matmul returns a NumPy array. And also let's just print like a smoke test and check like what kind of values does it return and how do they look like. So now we're on this. It should be doing the matrix multiplication here. And as you can see, it does. You get this huge vector back, which has 4081 rows and 1 column. And here is all the scores for those days. Right. There's also one thing that I need to that I feel that I should mention in this video, because I started thinking about it. When I say that these need to sum up to 1, there is also another rule for this, saying that you cannot have any negative values in here, because if something is affecting it negatively, you should instead reverse the value and not reverse the weight here. So like no negative values. These need to be positive in the way that they need to be equal or greater than 0 and less than or equal to 1 for each one of these columns here. So that is just a side note from the previous tutorial that I started thinking about. All right, so I hope this wasn't too confusing to you, and at this point I suggest that you pause the video and then you check out the resources. Especially I like the Khan Academy video here where he illustrates how matrix multiplication is done. So take a little bit of time into researching that, and also keep in like the back of your head, like trying to remember what we're actually doing here when we combine this constant with the x values here. So see how that relates to it basically, because that is a really good use case why we even have matrix multiplication to start with. Alright, so I hope you guys like this video, and leave any comment if anything is unclear, and don't forget to subscribe if you haven't already, and I will see you in the next video. See you, bye bye.